video for a second. Okay, let me show you how to do a free fall problem when I'm going to ask you to find a time for a particular height. So this is like free fall graph worksheet number 5 from chapter 5. And the height equation, this is number 3, the second one. We're going to throw an egg upwards off a 37-foot high bridge at 88 feet a second. Negative 16 is going to be due to gravity on Earth. And I want you to find the parabola, graph the parabola with 9 dots. So let's go through, let me show you how to do that. So here's the equation, negative 16t squared plus 88t plus 37. And it says, we'll start out by, so I wrote the height equation, that's the first step. And now what we're going to do is we're going to find the x-intercept. So find when it hits the ground. We're going to take this equation and make it equal to 0 because the height is going to be 0 when it hits the ground. We're going to find the x-intercepts and the axis of symmetry using the quadratic formula. So the quadratic formula says, you know, if this is the equation, this is A, B, and C. So A is negative 16, B is plus 88, C is plus 37. So the quadratic formula says it's negative B over 2A plus or minus the square root of B squared minus 4AC all over 2A. So for us, that's going to be negative 88 over 2 times negative 16. So that'll be negative 32. 2A is negative 32 plus or minus the square root. And we calculator to do this. And it's going to be 88 squared minus 4 times negative 16 times positive 37, all divided by 32. You can put a negative in there if you want, but because we're going to add and subtract it, you don't really need a negative there. So let me do the inside the radical here. 88 squared. I'm minusing a negative, so I'm actually going to be adding. So it'll be plus 4 times 16 times 37. So that's the square root of 10,112. So let me take that square root, and that's 100.56 divided by 32. And I'm going to put that in memory. So it's going to be 3.14. So it's going to be plus or minus 3.14. 88 divided by 32 is 2.75. So where it hits the ground are going to be 2 points. 2.75 plus, recall A, is 5.89 seconds. And then 2.75 minus, recall A, is negative 0.39 seconds. So there are the two x-intercepts at 5.89, so I can put that in here. And 0 is the height, and negative 0.39, and 0 is the height there. So if we mark that on our graph, it would be like one graph over here and negative 0.39 right around there. Okay? Next, and also, by the way, the 2.75 is going to be the axis of symmetry. So that negative B over 2A is always going to be the axis of symmetry. So I can put 2.75 on my graph as well. That's going to be right around here. So vertical line, the axis of symmetry, 2.75. That's going to be the middle of our graph. All right, now, next, well, let's find the vertex. And I'm going to do two things here. I want to find the vertex, which of course is going to be 2.75. So I'm going to put 2.75 in memory. That'll make it a little bit easier. And then I also want to find the height at 1.5 seconds. So I'm going to put 1.5 seconds in memory also. All that does is it's going to save me a little bit of time. I can just enter the equation once. So I go negative 16, recall A squared, plus 88, recall A, plus 37. So the vertex is going to be at 158 feet. 2.75 seconds, 158 feet. And then to try to find the height when it's going to be 1.5 seconds, I just have to scroll through here, change that A to a B. And the height at 1.5 seconds is going to be 133 feet. So it's just a way to save a little bit of time if you put the 2 points into memory and then you just have to change A to B in the equation. You don't have to type the whole thing in over again. Okay, the symmetric point is going to be 2.75 minus 1.5. 2.75 minus 1.5 is 1.25. And then I add the axis symmetry to that point, and that'll tell me the symmetric point. So plus 2.75. So I found 1.25 is the difference between the axis symmetry and 1.5 seconds. Add that to the axis symmetry, and I get 4 seconds. So the symmetric point, when it's going to be back to 133 feet, is 4 seconds. Okay, so the difference between here and here, I'm sorry, between 2.75 and 1.5 is 1.25. You add that to 2.75, and that gives us the axis symmetry over here. So we've got a bunch of points now. Let me plot these. So 158 is going to be right there at the vertex. 1.5 is 133 feet, so that's going to be right around here. And 4 seconds, it'll be back to 133 feet, so that's going to be right around here. So we've got kind of what's going on up there at the top of our graph. It looks something like that. The y-intercept is going to be, of course, at 37 feet. So it's going to be 0 and 37. The number by itself is always the y-intercept. And then the symmetric point to that is just going to be the axis symmetry doubled. So 2.75 times 2. And that'll be 5.5 seconds. It'll be back to 37 feet. So that's over here. I put that in the wrong place. Let me replot that. So it goes on the y-axis. I put it over here initially. Make sure it's on the y-axis, 37 feet. And then over here, 5.5 feet. It'll be back to 37 feet. So right around there. Okay. Now, here's the new part. The 2 points when the height equals 90. Okay. How do you find that? Well, you take the height equation, negative 16t squared plus 88t plus 37, and you just make it equal to 90. So if I want to know when the ball or the egg is going to be at 90 feet, I just take the height equation and I make it equal to 90. Now I solve that by bringing this, minusing 90 feet from both sides. To use the quadratic equation, it's always got to equal 0. So I go 37 minus 90, and I get negative 53. So I get a new equation, negative 16t squared plus 88t minus 53. So instead of plus 37, when it's going to be at 90 feet, it'll be minus 33. 37 take away 90 is negative 53. And now I use the quadratic equation over again. It's a little bit easier this time. So t is going to equal negative b over 2a. That doesn't change. So I still know it's going to be 2.75 plus or minus. Now it's going to be 88 squared minus 4 times negative 16 times negative 53. And again, divided by 32. So let me do this. 88 squared. And I'm minusing these negative times a negative is going to be positive. So I'm minusing 4 times 16 times 53 is going to be 4352. So it's the square root of 4352. You don't have to write down all these intermediate terms. So it's going to be 2.06. So it's going to be 2.75 plus or minus 2.06. So I put that in A, 2.75 plus, recall A, is going to be 4.81. And then 2.75 minus A is going to be 0.69. And they're both seconds when the height will be 90 feet. So back over here on my graph, I'm going to put down 90 as the height, and the time is 4.81 seconds and 0.69 seconds. So here's another couple of points that I can plot at 90 feet at 0.69. That's right around there. 90 feet and 0.69, and 90 feet and 4.81 is going to be, I don't know, right around there. So now I have 9 dots on my graph. And it should be a nice smooth parabola. So is that clear how you find, so I can ask you, if I give you a time, you plug the time into the height equation to get the height. If I give you a height, you put the height equation equal to that height, and then you use the quadratic formula to solve for time, and that'll be the time when the ball or the egg is at that height. And then you plot those points. So we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9 dots on our graph this time. Okay? So one more thing to add to your techniques of solving quadratic equations and graphing freefall problems. If I give you a height, you can tell me the time that the ball will be at that height. So practice that.